Hi, Assalamualaikum. My name is Muhammad Namullah. I am from Group 5 EC1104F, and this recording is for assignment ECS246. Prepared for Dr. Mazaki bin Abdul Rahman. Okay, question. Glass is seen as a new potential material to replace limestone in the making of cement powder. This is because limestone is a non-renewable material and requires a lot of pollution and deforestation to harvest it. While we have abundance of waste glass that is left to be decomposed in the landfill, even though glass cannot be decomposed by land, so this replacement seems to be the game changer in the industry, and it is eco-friendly. Glass is made out of silica carbonate, or basically just from the beach sand that is heated a few thousand Celsius in the oven. Then it will be shipped directly out from the oven while it's still melt like lava.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ali Ashraf. Today I want to talk about the article about sustainable green environment through utilizing of waste soda lime glass for production of concrete. So for introduction, as the population grows, so as the glass sustainable growth. There are industrial and infrastructure, residential construction being built every day. As the construction are built, there are also demolition waste that are scattering around area. We can use the waste to recycle and make them as a useful and better things. The waste should not be looking as a rubbish, but we can look it as a material or resources that can be used for a lot of purpose. And then we can reduce the greenhouse gas emission if there's any fuel waste material. According to the research, there is a steady increase of in a quantity of glass generated in a recent year due to the continual production of usage glass product. A huge part of this generated waste glass are dumped into landfill sites. Therefore, in order to find an environmental friendly solution in managing the waste glass material, extensive investigation has been carried out on the waste glass in concrete form as a crushed granular or powder material as a replacement for the aggregate in Portland cement and in concrete production. So the objective of this journal is to investigate the effect of substituting granite with a soda lime glass crushed into a cross granular aggregate size, the workability, splitting tensile and compressive strength of the result of the concrete. So the experimental methodology, firstly we use the slump test. As we know that all mix into proportion 1, 2 and 4, which is cement, sand and granite. Also the glass aggregate and the constant water, which is 0.5, and then we as the table below we can see the 5 tests of the experiment, which is the percentage of the cement water and the glass, which is 25%, 50%, 75% and 100. So next is the compressive strength test, which is the concrete cube was made and immersed into the water at room temperature and test for the compressive and split tensile strength at age 3, 7, 14, 28 and 90 days. For each percentage of replacement granite granular waste general glass aggregate material. The compressive strength of concrete cube and the split tensile strength of the concrete cylinder were determined in compliance with the provision by using YES 2000 digital display compression machine. So lastly is by scanning electron microscopy, SEM, The microstructural examination of fractured part of the concrete were carried out using the scanning electron microscopy SEM. It can determine the type, the amount of size, shape, and distribution phase present in the material form in the microstructure, and through the SEM technique, it is possible to analyze the microstructure of the material to a fraction of 1 micrometer. So for the discussion and the result, for the slump test, it can be clearly observed that the slump test decreased with the increase in the percentage of waste glass, as the graph at above. This reduction in slump may be attributed to any angular geometry of the granular particle of the glass, which reduce the fluidity of the mix as the glass content increase, resulting in availability of cement paste required for the concrete fluidity. Moreover, for concrete containing glass aggregate to achieve a same workability with conventional concrete, it will require high water content. However, all mix are workable with no excessive segregation, especially for the concrete mixture containing 25% with glass coarse aggregate. Next is the compressive strength. From the graph above, it's clearly indicate that as the percentage replacement of granite with the glass aggregate increase beyond 25% replacement, the compressive strength of the concrete decrease at early curing age of 3 and 7 days. Later, the curing age of 28 and 99 days. The decrease of the compressive strength of the concrete at both 28 and 90 days of curing shows strongly correlated. They observe lower compressive strength of the concrete mixture containing 75 and 100 granular aggregate was attributed to the weaker bond strength between the sharper edge and smooth surface of the glass particle and the cement paste matrix at interfacial transition zone ITZ. So lastly is from scanning electron microscopy SEM. So as we can see, the microstructural examination SEM on selected concrete containing glass aggregate were conducting further assess of bond between the cement paste at the interfacial zone. So the bond is between the cement paste is very important, that require the movement of the stress, so its make is have many gaps. So it's clear that the glass aggregate particle have a smooth surface interfacing with the cement paste, thereby proving poor interlocking between the two phases, which may result of poor mechanical properties of the concrete.
Strength and microstructure of aqua concrete produced using waste glass and partial and complete replacement process. Introduction. The benefit of using waste glass as a substitute for natural aggregate in concrete offer a promising environmental solution to the growing problem of efficient management of glass waste in the developing nations. Glass is an indispensable material to man and one of the oldest man-made materials on Earth. Because of its properties, glass can be formed into many shapes and forms, which include flat glass, bird glass, container or bottle glass, and cathode tube glass. However, glass has a limited life usage in the form in which they are produced. Moreover, based on chemical composition, glass can be classified into different categories, with the most widely used and readily available glass type being soda lime glass. Waste glass offer equal alternative options as a replacement material for conventional aggregate in concrete, and incorporating crushed granular waste glass as aggregate in concrete not only benefit the environment but also reduce the need for extracting raw material. Several research studies have been conducted on recycle and reusing of waste glass as a substitute of the use of natural aggregate in concrete. Several research studies have reported the limitation on the use of glass aggregate in concrete, which is the susceptibility of the glass aggregate material to chemical attack under high alkali environment for the hydride cement paste in concrete or mortar, resulting in the formation of alkali silica reaction. The reactive silica in glass interacts with the reactant silica in glass interacts with the alkalis in the concrete process to form a gel, and when this gel absorbs water it will resulting in concrete instability and cracking. However, studies have reported some positive outcome on mitigating the effect of ASR gel that occur due to the interaction between the alkali in the pore solution of cement, concrete, and methodology. All concrete material used in this current study were locally sourced. Typical ordinary Portland cement which comply with ASTM Type 1 cement suitable for general purpose construction was used. The chemical composition of the cement was determined according to ASTM C114 using X-ray fluorescence. The chemical composition and physical properties of the cement are shown in Table 1. The waste glass was collected from different waste disposal sites and glass workshop with the environment of OTA Nigeria. The collected glass was contained majority flat glass and container glass. After collection of the glass the glass were soaked in water. Then the glass were washed and air dried openly. The essence of this was to remove contaminants, paper and plastic, labor, metal, and dirt that before crushing the glass to the required particle size. The chemical composition of the waste glass was determined using the X-ray fluorescence. The natural fine and coarse aggregate used during this research work were commercially obtained. The natural sand of 4.75 mm maximum particle size having its particle size gaining conforming to ASTM C136, while the gravel having a maximum size of 19 mm was used in this study. The particle size gradation for the glass sand, natural sand, and gravel aggregate were carried out using safe analysis and are presented in figure 1. The metallic oxide composition of the cement, the alkali compound of the Portland cement was 0.18%. The chemical composition clearly depicts the cement material having a high percentage of CO content. The result of the chemical composition of the crushed was glass particles show that the glass has high percentage of silica content and sodium compounds, which indicate the glass material to be soda-land. The sieve analysis performed to analyze the particle size distribution of the material are present in figure 1. The sieve plots for the natural aggregate show a consistent gradation of the particle size distribution, while the gradation curve for the waste glass fine aggregate also show a very similar uniform gradation of particle size distribution, and compare well with the reverse sand used for the concrete production. Result of the sieve analysis indicate that the crushed glass sand particle can be used to substitute sand material or blend with the sand material. Result and discussion. 1. Properties of fresh concrete. Workability. The test result for the slump recorded for the control and mix containing fine glass sand at the different proportion are shown in picture 1. The results show the initial true slump volume of 55 mm for the control mix, while the mixture contained with glass sand show a reduction tendency in slump, ranging from 9% to 37% in response to the increase in the waste glass content. The decrease show a strong correlation value of R equal to negative 0.97. Slump is used to determine the consistency of concrete mixture. The decrease in the consistency of concrete with increased glass content may be as a result of the grain shape and angular geometry of the waste glass particle, which reduce the amount of cement parts and hence reduce the fluidity of the concrete mixture. Next, compressive strength. Picture to illustrate the compressive strength variation of control concrete and glass sand concrete for curing period of 3, 7, 28, and 90 days respectively. The result clearly indicate that the use of glass content show an increase in compressive strength from the early curing age of 3 days to 90 days. Moreover, concrete contain 50% glass content also show comparable strength as those of the control concrete for all curing age. The concrete mix containing 25% and 50% glass content outside replacement achieve a 28-day compressive strength. Last, splitting tensile strength. The splitting tensile strength test results are presented in Figure 3 for various curing aids. The recorded splitting tensile strength for the glass and concrete variable between 2.18 megapascal and 2.78 megapascal at 28 days curing. Moreover, Picture 3 depicts the split tensile strength result at 19 days of curing to between 2.8 megapascal and 3.61 megapascal, which is lower than the 4.20 megapascal achieved at 90 days for the control. The observed test result clearly indicate that the increase in the proportion of glass sand content in the concrete mix lead to the decrease in the split tensile strength of the concrete, which may be attributed to the decrease in the achieved strength of the glass and sand concrete as the proportion of the glass content increase. Furthermore, the decrease in strength may also be as a result of the non-homogeneous distribution of the aggregate owing to glass shape and geometry.
For the recommendation is using the glasses such as AIS consist a low E high performance energy efficient glass. It can help a green building achieve great balance between all the parameter and block a high amount of solar radiation by reflecting away the infrared part of sunlight. This help building remain variably cool in summer and cut down on the energy bill and air conditioning usage. Furthermore, the biggest advantage that make glass a major component in green building is the fact that it is recyclable and also does not have a huge impact on the environment. Glass can play a role in accomplishing greater indoor environmental quality and when used carefully can also improve energy efficiency along with tangible benefit. Glass can also provide enhanced air quality, excellent daylighting and general health and well-being of occupant. Through a global point of view, conservation of scarce national resource is also a huge advantage where it widespread acceptance and enhanced marketability for the project made it viable option for the industry too. And for the conclusion is glass have potential to replace limestone in the making of cement powder. This is because limestone is a non-renewable material and require a lot of pollution and deforestation to harvest it. While we have an abundance of waste glass that is left to be decomposed in the landfill, even though glass cannot be decomposed by land. So we can recycle all the waste glass by that is just peeling up in the landfill and turn it into useful material, and at the same time we may slowly decrease the usage of limestone as it requires huge land mass to be cleared just for mining it, while avoiding elements that can be disposed and decomposed by earth at the landfill. That's all. Thank you.